So we've already talked about solving systems of equations with graphing and with substitution. Today we're using the elimination method. And the elimination method is a method for solving systems of equations by adding or subtracting to eliminate a variable. There are 4 steps that you want to use to solve a system of equations by using the elimination method. Step 1 is to make sure your equations are lined up. So make sure all your x terms are lined up, all your y terms are lined up, and then any other leftover terms are also lined up. Step 2 is to either add or subtract the equations to eliminate the variable with common coefficients. Okay, so you're looking at, say for example, you have a 3x and a 3x in both of your equations. That's what we're talking about by common coefficients. They're going to be the same, but one could be positive, one could be negative. Step 3 is to solve for the remaining variable. And this will all make sense once we actually do some examples. Okay, step 4 is to substitute your answer into either original equation and to solve for the other variable. So we're going to try a couple examples, and then you're going to do some practice on your own. So our first example is this, number 1. Okay, we have y equals 3x plus 4 and y equals x minus 2. Now our common coefficient here is y. They both have y equals and y equals. So we're going to use that as our common coefficient in order to solve this problem. So these are already lined up. All my y terms are lined up together. My x terms are lined up together. And my leftover numbers right here are all lined up. So what I'm going to do is I'm either going to add or subtract. In this case, I have a positive y and a positive y. So if I want to get rid of one of these, I need to subtract. So what I'm going to do is I'm going to subtract down here, and I'm going to make all of those now a subtraction problem. So what I'm going to do is I'm going to do y minus y, which I know is 0. 3x minus x is 2x. 4 minus a negative 2, so that's addition. So 4 minus a negative 2 is a positive 6. Okay, so now I want to solve this for the remaining variable. So 2x plus 6, I'm going to subtract 6 from both sides. And then I need to get to x by itself, so I'm going to divide both sides by 2. And I get negative 3 equals x. So now I'm going to take this and I'm going to substitute my answer into either original equation, whatever one is easier for you. I'm going to use the bottom one because that is the easier one to use. Okay, so I plugged in my negative 3. I'm subtracting 2. Y equals negative 3 minus 2, which means y equals negative 5. Now these two numbers here are my ordered pair. So my solution is negative 3 comma negative 5. Let's try number 2. So again, our first step is to make sure that we have everything lined up, and we're going to eliminate one of our variables. Okay, so I have my x's lined up, my y's are lined up, and these numbers are lined up. So I'm going to go ahead and I am going to eliminate the one with common coefficients. In this case, it's my x terms. So I'm going to go ahead and do a subtraction of everything. So x minus x, that gets me 0. Okay, so that's just gone. 4 minus a negative 1 is a positive, right? So 4 plus 1, that's 5y. And then 13 minus 3 is 10. Now I can go ahead and solve for my remaining variable, divide both sides by 5, and I get y equals 2. So now I'm going to take this and pick either expression, either equation to plug it in. I'm going to use this one down here. So I'm going to go ahead and do x minus 2 equals 3. Add 2 to both sides, and I get x equals 5. So my solution is 5 comma 2. Okay, I'm going to put a box around these so that way I know this is my solution. So it's easy to spot. Number 3, same idea. However, this time we don't have a 1 as our coefficient. This time our common coefficient is a 3. So our x's are lined up, our y's are lined up, and our numbers are lined up. So what we're going to do is we are going to go ahead and eliminate one of these. So I'm going to go ahead and subtract, because that's going to be how I eliminate here. 3 minus 3, okay, we know that's 0. Negative 10 minus a negative 9, so negative 10 plus 9. Negative 10 plus 9, I know, is negative 1. Okay, so I'm just going to write that as negative y. And then 14 minus 15 is negative 1. Divide both sides by negative 1, and I get y equals 1. So now I can pick either one of these. Doesn't matter which one. I'm going to go ahead and plug this into the top one. So I'm going to have 3x minus 10 times my y value equals 14. So 3x minus 10 equals 14. Add 10 to both sides. Divide both sides by 3. And I get x equals 8. So my solution is my 8, comma, my 1. All right, I'll try one more. So again, we need to make sure that we are either adding or subtracting after they're all lined up. My x's are lined up, my y's are lined up. Perfect, okay? So I'm going to go ahead and solve this. I have my 2y and my 2y here. So I know I'm going to have to subtract because they're both positive. If it was 2y and a negative 2y, I could add. But this is 2y and a 2y, so I'm going to subtract. So 4 minus a negative 2. 4 minus negative 2 is the same thing as 4 plus 2. 4 plus 2 is 6. 2y minus 2y is 0. 6 minus 18 is negative 12. Divide both sides by 6. Right, so that's my x term. I'm going to go ahead and plug this in to one of these. Doesn't matter. I'm going to use the top one because I don't want to use that negative there. So 4 times my negative 2 plus 2y equals 6. 4 times a negative 2 is a negative 8. Copy everything down. I can add 8 to both sides. Divide by 2. So my ordered pair here is my negative 2, comma, 7. So what we're going to do is you're going to try the next one. So go ahead and try number 5 on the back. All right, if you've tried number 5, you should have this as your work. Now you'll notice here, since we have our common coefficient of 4 and a negative 4, that this time I'm going to add, because this is already going to cancel itself out. So I don't need to subtract this time. 4 plus a negative 4 is going to get me 0. 9 plus 7 is 16. 5 plus 11 is also 16. Divide by 16 and I get 1. Plug 1 in. Doesn't matter which one. We use the top one. Solve. Get your solution. Try 6. All right, for number 6, you should have gotten the answer of 3, 4. Again, this one, there's a negative and a positive here. So this time we don't need to subtract. We need to add. So negative 3 plus 3, that cancels out. So 10x plus negative 2x is 8. 10 minus 2 is 8. 18 plus 6 is 24. Divide by 8 to get 3. Plug that back in for x because we solved for x. So 10 times 3 minus 3y equals 18. Go ahead and solve that and you get 4. So that's why our answer is 3, 4. Try 7. For number 7, it's another one we have to add because we have a negative y and a positive y. So we're going to go ahead and add this time. That'll cancel each other out. X plus 3, that's 1x plus 3x is 4x. 10 plus 18 is 28. divide by 4 to get 7. Plug that back into one of the originals, doesn't matter which. So we did 7 minus y equals 10. Okay, so when you solve that, you get negative y equals 3, so y must be a negative 3. Try 8. For 8, you should have gotten an answer of 5, negative 2. For this one, okay, they're not lined up correctly. So step 1 is to make sure that you are lining them up in order from x, y, and then your just normal number. So our x here, we have to move the y over here, so that's why we have x minus 3y equals 11. Okay, because they're not lined up, the equal signs weren't lined up. Once you have them all lined up, you can go ahead and solve. So I have x, I have 2x, I have negative 3y and negative 3y, and then I have 11 and 16. Since these are both negative 3y, I'm going to subtract to get rid of 1. So x minus 2x, so 1 minus 2 is negative 1. Negative 3 minus negative 3 is 0, so we don't have to write it. 11 minus 16 is negative 5. Divide that by negative 1 to get x equals 5. Plug 5 back into either one of the original equations. So you can use this first one. So 5 equals 3y plus 11. Subtract 11 from both sides, divide by 3 to get your answer. Try 9. Okay, for 9, you also had to make sure that you were flipping around your equation. Okay, we had to make sure we got the x term onto this side. So we should have subtracted 2x from both sides to get negative 2x plus 4y equals negative 8. And then you're adding 5x minus 4y to equal 20. So negative 2 plus 5 is 3. Since these are opposites, a positive 4 and a negative 4, we're going to add this time. So positive 4 and negative 4 is 0. And negative 8 plus 20 is 12. Divide by 3 to get 4. Plug that back into one of the original ones. It doesn't matter. And you can go ahead and solve and get 0. So your solution is 4, 0. Try 10. For 10, this one's a little different because as you can see, our coefficients are the same for both terms. We have positive 3x, we have negative 4. So to get rid of these, I need to subtract. I'm going to do 3 minus 3. That'll give me 0. But negative 4 minus negative 4 is also going to be 0. And then negative 10 minus negative 13 is a positive 3. Clearly, 0 does not equal 3, so that's when we have no solution. Try the next one. So this one is a little different as well. Last one was no solution because the numbers didn't equal each other when we were done solving. However, in this one, everything's the opposite. We've got positive 2, negative 2x. Positive y, negative y. Negative 10, positive 10. Everything is the opposite after we rearrange the problem. So, since everything's the opposite, 0 obviously equals 0 because if you're going to add, 2 plus negative 2 is 0. Y plus negative y is 0. Negative 10 plus 10 is 0. 0 does equal 0, so that's when we have infinite solutions.